We left off talking about solving quadratic equations using the square root property. We're going to expand on that a little bit by looking at completing the square, and then once we have what we call a perfect square trinomial, we're going to use the square root property to solve our quadratic equation. Let me show you what I mean. So at the beginning here, you have this box that says, if given x squared plus bx, then you can add b over 2 squared to it to get a perfect square trinomial. So if we add the b over 2 squared to the x squared plus bx, what happens is that becomes something that can be written in factored form where it is a perfect square, so a quantity squared. Couple of important things here. This only works when you have a coefficient of 1 on the x squared, and so be very careful of that. Notice what we are doing is we are taking this number here, the b, dividing it by 2 and then squaring it. So that's going to be our process here. This first example says what term should be added to each binomial to complete the square of the following. So we are in that form x squared plus bx, where b is 4. We are going to take the b, which is 4, divide it by 2, and square that quantity. Well, 4 divided by 2 is 2, so that works out to be 4. What happens when we do that is we get x squared plus 4x. If we add that 4, this becomes a nice, pretty, perfect square. X plus 2 quantity squared is what you get there. Okay, so that's what we're going to do. Let's try the next one down here. This one's a little bit more complicated because completing the square works when you have a coefficient of 1 on x squared. We are going to factor out the 2 there and rewrite this expression as 2 times the quantity x squared minus 3/2 x. Notice if we distributed that 2 back in, we would get what we started with. So then in this case, that makes our b negative 3 over 2. When we take that number and divide it by 2 and square it, remember dividing by 2 is the same thing as multiplying by 1/2. So that's actually negative 3/4 squared, or 9/16. So this one gets a little yuckier because we now are going to rewrite this as 2 times x squared minus 3/2 x plus 9/16. And then that is 2 times the quantity x minus 3/4 quantity squared is how that one would factor. Now that one's a little bit harder to see how it factors. One thing I also want to make very, very clear. This result that we get after we complete the square is not equivalent to what we started with here. This that we started with, in this case, x squared plus 4x, not the same thing as this, right? So of course it's not equal to the x plus 2 squared. So just be careful. We are adding something there that changes the expression. I don't want you to say that this 2x squared minus 3x is equivalent to what we got here, because they are not. We added something to it, so we changed it. What I do want to look at is where did I get this sort of factored form, this x minus 3 quantity squared. Hopefully you can see that I brought the 2 down, and that's why that is staying there. But where did this 3 minus 3/4 come from? Well, if you look back up here in our box, what goes here, this right here, what's inside your square is the b over 2. In that case, in this case, the b was -3/2. When we divided it by 2, it is what is inside this parentheses before we squared, right? Which is that -3/4. And that is what ended up here. That's why it's a minus sign. It's a little bit easier to see, like, once you have the factored form, when you multiply it out, that you do get this. It's a little harder to go the other way. But just know that it's the b over 2 that goes in this spot. Okay? In this case, that b over 2 was -3/4. All right. Let me show you how we are going to use this to actually solve an equation, a quadratic equation. This that we are given here in the middle of this page, let's scroll that up a little bit, the top of this page is a quadratic equation. You have the x squared, that makes it a quadratic. It asks us to solve this by completing the square. I think when we have an equation, the easiest way to do this is to subtract 9 from both sides. And I'm going to leave a little bit of space. So I'm going to go in here, subtract 9 from both sides. I'm going to leave a little bit of space in there so that we can work in that space. That is where we are going to complete the square. In this case, when we're looking at the x squared minus 8x, our b is the -8. When we divide that by 2 and square it, we get -8 over 2 squared, which is -4 squared, or +16. I am going to add that 16 in on the left side of this equation, but it's an equation. I have to keep it balanced, so we add 16 to the right side of the equation. I have not changed this equation. I have changed what it looks like, but I haven't changed the balance of this equation. It is still equivalent to that x squared minus 8x plus 9 equals 0 that I started with. And you may be thinking like, okay, why would we do this? Well, the reason we do this is because now the left side factors into x minus 4 quantity squared. The right side is just 7. That factor, that -4, remember, it is the b over 2. It's this before you square it. Okay, if you're wondering how do I find that, hopefully you can factor x squared minus 8x plus 16. But if not, that is where that comes from. If not, go back and work on some factoring because you need to be able to do that. Next, we are going to use our square root property to actually solve this. Remember, when I'm trying to solve it, I'm looking to find the x that makes this equation true, x or x's. We are going to square root both sides of this equation using that square root property, just like we saw in our second method for solving quadratic equations. When I have anything squared equal to a constant, I can square root both sides. You don't want to do it if you don't have a constant on the right side of this equation, but if you have a constant on the right side of the equation and a quantity squared on the left side, or even if those are flipped, then you want to square root both sides. What that gives us is x minus 4 is equal to plus or minus the square root of 7. Square root of 7 does not simplify. We need to get the x by itself, so we add 4 to both sides of this equation. X equals 4 plus or minus the square root of 7. We have two solutions here, right? X equals 4 plus root 7, x equals 4 minus root 7. So those are solutions to this quadratic equation. This is not something that factors, by the way, this x squared minus 8x plus 9 equals 0 that we started with. X squared minus 8x plus 9 does not factor. I should have mentioned that at the beginning because that's the first thing I'm going to try. If it's something that easily factors, I want to try it. But there are no two numbers that multiply to give me 9 that add up to negative 8. Okay? You might be thinking 9 and 1, but those add up to 10, and even if they're both negative, to give you positive 9 for a product, they add up to negative 10. So that does not work. Factoring doesn't work here. So that's why I used completing the square. I also know that factoring did not work because the result that I got was not rational numbers. I got that root in there. Okay, let's try another one, solving another one, completing the square that's maybe a little bit more complicated. Solve 2x squared minus 4x minus 1 equals 0 by completing the square. You are always welcome to pause the videos and try this on your own if you want. Like if I do a second example, feel free to do that, okay? But these are here for your, extra guidance if you need it. The first thing that I notice is that this coefficient on x squared is not 1, okay? It's a quadratic equation, but my coefficient on x squared is not 1. So I need to deal with that. I am going to add 1 to both sides of this equation so that I have 2x squared minus 4x equals 1. And then I'm going to factor out the 2 there. I'm going to leave a little bit of space because that's where I'm going to complete my square. We call it completing the square because I'm completing the perfect square trinomial. It's not a perfect square trinomial as it is, but I'm going to put some work in there that does complete that. Okay, so now I still have something equivalent to what I started with. What I want to do here is I'm going to take my b, which is negative 2. I'm going to divide it by 2 and square it. That will always give me the perfect square, the thing that I need to complete my perfect square. So in this case, I divide by 2, I get negative 1, I square it, and I get positive 1. So I want to add 1 here. If I just add 1 to the left side of that equation inside the parentheses, I have changed the equation, which means I have changed the solutions to the equation. So I can't just add 1 there. I have to add something to the other side of the equation to keep it balanced. An equation is like a scale. You got to keep it balanced. If you do something on one side, you have to do it on the other side. In this case, that thing that I need to add is actually 2 on the right side. Whoa, wait, what just happened there? Why did I add 1 on the left side and 2 on the right side? The answer to that is this 2 out front. If I were to distribute that out, what I actually added to the left side of this equation was 2, because the left side of this equation with that plus 1 in there is equal to 2x squared minus 4x plus 2. That 2 on the outside still impacts the total net gain on the left side of the equation. So that is why we added 2 to the right side. All right. The 2 is still hanging out there. X squared minus 2x plus 1 factors into x minus 1 quantity squared. Think about if you had x minus 1 times x minus 1. Foiling or distributing that out would give you x squared minus 2x plus 1, which is exactly what you have inside the parentheses on that second line there. And we are equal to 3, 1 plus 2. And we're going to use our square root property. That means isolate the thing that is squared, the quantity that is squared. So divide both sides by 2. Both sides of the equation. And you have x minus 1 quantity squared is equal to 3/2. And we square root both sides. And we end up with x minus 1 is equal to plus or minus the square root of 3/2. If you wanted to rationalize that, you can. That would be plus or minus the square root of 6 over 2. And that just comes from multiplying by root 2 over root 2, a fun form of 1. So we get root 6 over 2. And then add 1 to both sides. X equals 1 plus or minus the square root of 6 over 2. You also might see that as 2 plus or minus root 6 all over 2 if you get a common denominator between the 1 and the root 6 over 2. So either one of those, this form or this form, would be an appropriate set of solutions to this equation using completing the square. That is how we solve quadratic equations using completing the square. Hang tight for a third video to look at an additional method for solving quadratic equations.